The first question you may ask is, what is a qubit? This video explains the basics of quantum computing. Starting with the comparison, we see that the classical bit is classified as a binary digit and is represented by a 0 or a 1. A qubit is a quantum bit that behaves just like a regular bit, but it can also store a combination of 0 and 1 at the same time. Alpha and beta are coefficients in this qubit representation. A basic representation is this qubit. It is set as ket 0, where the word ket comes from the structure of the notation bracket. So ket 0 represents a qubit in the 0 state, which is the most basic quantum state. A quantum state represents the complete description of a quantum system. We see that it's shown as this vector, which shows a single qubit state. A multi-qubit state is shown as this, which represents all possible combinations of two qubits. The Greek letters are the coefficients of the qubits in this quantum state. The coefficients squared have to sum up to 1. So the probability of ket 0 is alpha squared, and ket 1 is beta squared. This equation ensures that the total probability equals 1, which maximizes the probability. Now we're going to look into a graphical representation of a qubit, which is called circle notation. A quick note is that the inner circle represents the magnitude and the line represents the angle of the qubit. Looking at the inner circle is determined by the coefficient of the qubit state. The size is proportional to the area of the circle and is found by squaring the coefficient. In this example, the coefficient is 1 over square root of 2, so the inner circle should be half the size of the original circle because the coefficient squared is 1/2. Now I'll give you a quick unit circle recap. Looking at the x and y axis, we draw a circle, and the radius of the circle is 1. On each axis is labeled with the coordinate. The right side of the x-axis starts with 0 and adds pi over 2 as you go to each axis in a counterclockwise direction. The point on the circle is the coordinates in the form of cosine theta sine theta, where theta is the angle of the line from the x-axis starting at 0. This angle shown is pi over 4. With this in mind, the line for the circle notation actually starts at pi over 2 angle. So let's look back at circle notation. So since 0 starts at pi over 2 from the original unit circle, the indicator is the exponent of e. So in this example, e is raised to the power of pi over 4. So the line will be 45 degrees past the starting point. Now let's look into a full example of circle notation. We have the inner circle and the angle, and the coefficient is 1 over the square root of 2, and the exponent of e is pi over 4, so the figure is shown applying those aspects. In conclusion, now you know the first building blocks of quantum computing, and we can utilize circle notation as a useful tool to visualize a quantum state.